Welcome students. Today we are going to discuss about Biot Savart Law. So Biot Savart Law is the very basic law for magnetic field intensity, as we are discussed Coulomb's law in electric field intensity. No, same way. So the Biot Savart Law explained that the differential magnetic field intensity (dH) produced at any point P by the differential current element IDL is proportional to the product of differential current element and sine of the angle between the element and the line joining P to the element, and is inversely proportional to the square of the distance between the element. It's a statement of Biot Savart law. Now I am explain what it means. So Biot Savart discovered the law which has, suppose take a current carrying conductor, any current carrying conductor, which carries current I. So now in this I am taking a small elementary length dl. Suppose consider a point P at a distance of r from this small elementary part P. The electric flux density B or electric field intensity H at point P is directly proportional to the product of current into small elementary part I into dl and the angle at which point P line joining from the current element and the current flow through this, that angle theta, this value theta. So sine of this angle divided by and then inversely proportional to what is the distance from center to the point. Here the point is r, so r squared. So dh is directly proportional to idl sine theta by r squared. So idl, I is the current, dl is the small elementary part, theta is the angle at point P makes to this small element, and r is the radial distance from center of the element. So this is the Biot Savart law. So for removing the value of proportionality constant, usually we are adding one constant k. So dh is equal to k I dl sin theta by r square. So usually k is the proportionality constant. So in normal SI units, k is equal to 1 divided by 4 pi. So you can replace it. So dh is equal to IDL sin theta by 4 pi r squared. So what is the relation between B and H? So B is equal to mu into H. Suppose I want magnetic flux density dB. So we can write dB is equal to mu into I dl sin theta divided by 4 pi r squared. So you'll get the value of electric flux density. So here sin theta. So according to your basics, so I into dl sin theta. So this is the vector product, not cross product. So cross product, cos theta only cross product. So sin theta. So we can write I cross dl. So I cross dl, according to our definition, we can write I cross dl into is the vector product. So I into dl into, so for vector you have to represent the direction as the unit vector ai. So we can write finally I into dl ar vector divided by 4 pi r squared. Again ar vector we can write magnitude of ar by r. So r into r become r squared. Sorry, r cube, r squared into r become r cube, because r we can write magnitude of r and ar is the unit vector. So we can write r vector divided by magnitude of r. So that r and r squared become r cube. So 4 pi r cube. So here it is the vector product. So we need to find out the direction. So the direction can be determined by using the right hand rule. So right hand thumb rule. So the rule says the hold the current carrying wire by your right hand. So using your right hand you hold this conductor and such that the thumb pointing the direction of current flow. So the other fingers encloses this conductor which shows the direction of magnetic flux. Look at the diagram. So here the current flow upward direction. So encircles the thumb points the direction of current flow. Thumb points the direction of current flow. So this finger shows the direction of magnetic field experienced by the conductor. So this is what we have to easily identify the direction of magnetic field. So and also we can easily identify by using screw rule, right hand screw rule. So you can tighten the screw by the direction of current flow. The direction of rotation of the screw shows the direction of value of magnetic field intensity. So this is the basic of Biot Savart law. So next class we will see Ampere's law. Thank you.